Okay, so the idea now is to show you for an invertible matrix, let's call it A, how we can find a formula for the inverse using the minimal polynomial. Namely, you will see that in the end we will get to this. The inverse of a matrix equals -1 divided by A0, which is a constant in the minimal polynomial, times this, and this is a formula for the inverse, and this is derived for the minimal polynomial. Let's see how it goes. We start with the minimal polynomial of the matrix. We assume we already have it, we've calculated it, eigenvalues and things like this. And this is the minimal polynomial, and we assume A is invertible, and it's very important. Because A is invertible in a minimal polynomial, the A0, this constant term in the minimal polynomial, is not 0. You can see a video that I did why for invertible matrix the A0, the constant term in the minimal polynomial, is not 0. So assume this is not 0. Okay, so we can take this, everything else, and take it to the other side. We get this one. Now we know that A is invertible. It must be, otherwise it won't work. So if so, I can take A out and take the inverse from the left side from each side of the equation. We are getting to this, right? And now I can just annihilate this A, and we are left with an equation to the power of k minus 1, which is exactly 1 degree below the degree for the minimal polynomial, which is k in our case, and we are left with this one. So I want to get a formula for the inverse of A minus 1. So take A0 to the other side, and we're getting to this, and here we are. We started from the minimal polynomial equation, and here we got to a formula, to an equation that tells you exactly what is the A minus 1, the inverse of a matrix. Of course, it doesn't seem very nice to calculate all those powers for the matrix, but it's very neat to see this derivation connecting the minimal polynomial, inverse, invertible matrix, and an equation to the inverse. So this is very nice. This is how we can use the minimal polynomial to derive an equation for the inverse of an invertible matrix. Thank you very much, and that's it.